For billions of years, life as we know it was born here on Earth. It stayed on Earth and died on Earth. But recent developments by a primate species known as Homo sapiens might be the ones to change it all. The International Space Station, orbiting about 400 kilometers above Earth, has been humanity's laboratory for long-term living in microgravity for over 2 decades. Astronauts aboard the ISS carry out daily routines that are both familiar and alien. They sleep, eat, and work, but the details are radically different from life on Earth. Food comes in sealed packets and must be carefully rehydrated. Sleeping quarters are small pods where astronauts zip themselves into sleeping bags to avoid floating into equipment. Exercise 2 hours per day is mandatory to counteract muscle atrophy and bone loss caused by weightlessness. Future colonies, whether on the moon or Mars, will adapt these practices but also require new survival strategies. Greenhouses and hydroponic farms will grow food on site, while habitats may be built using local materials such as lunar regolith or Martian soil. Life in space will mean engineering every part of daily life, from meals to homes to breathable air. Survival in space depends on advanced technologies. A central system is a closed-loop life support. Recycling air, water, and waste is needed to make sure that nothing is lost. On the ISS, water is reclaimed from both humidity in the air and even from human excretion. Power systems also define the limits of human habitation. Today's stations and probes largely rely on solar panels, but future colonies may need small thermonuclear power plants to provide continuous energy, especially in environments where sunlight is weak. Transportation is another frontier. It is the main reason why we are not living across the solar system already. Current rockets are expensive and inefficient, but new propulsion technologies such as ion drives and nuclear thermal engines could cut travel times between planets. Shorter trips means reduced radiation exposure and fewer supplies needed for survival. Machines can build habitats, mine resources, and perform repairs in dangerous conditions, helping human settlers to focus on exploration and community building. Technology may keep us alive, but the human mind is just as critical. Living in space brings intense psychological and social challenges. Isolation and confinement are two of the most difficult challenges. Astronauts already face this on the ISS, but future settlers will face even longer separations, with communication delays that can stretch up to 28 minutes for just Mars. In such conditions, management, cooperation, and emotion resilience will be vital. A possible solution to this is large language models, AI models that have already been used to provide therapy and companionship to the needy here on Earth. Radiation is another invisible yet powerful challenge. Beyond Earth's protective atmosphere and magnetic field, cosmic rays and solar storms pose constant risks to health. Shielding with thick walls, underground habitats, or even water layers may be necessary to keep long-term settlers safe. Humanity's next steps are already being planned. After decades of Neil Armstrong on the moon, NASA's Artemis program aims to establish a permanent human presence on the moon. This lunar gateway could become a testing ground for Mars missions.
where settlers practice living off the land using local resources.
Mars remains the ultimate goal for many people. Colonies there would face freezing temperatures, thin atmosphere, and constant radiation hazards. Terraforming, however, though much harder, will be a more permanent method to live on Mars. If we can change Mars's atmosphere to somewhat like Earth and use asteroids to make Martian oceans, we could, in theory, roam around Mars freely just like on Earth. We would have made a second home.
Mining asteroid resources could be the fuel to our ambitions. Eventually, interstellar travel, once purely fantasy and science fiction, may come within reach as the various technologies advance. For most of human history, the night sky was a distant mystery. The stars inspired myths, guided sailors, and sparked the imagination of countless generations.
But in just the past 60 years, what humanity has done is just the beginning.